Properties of metals, metalloids, and nonmetals. The chemical elements can be broadly divided into metals, metalloids, and nonmetals according to their shared physical and chemical properties. All metals have a shiny appearance, are good conductors of heat and electricity, form alloys with other metals, and have at least one basic oxide. Metalloids are metallic-looking brittle solids that are either semiconductors or exist in semiconducting forms, and have amphoteric or weakly acidic oxides. Typical nonmetals have a dull, colored or colorless appearance, are brittle when solid, are poor conductors of heat and electricity, and have acidic oxides. Most or some elements in each category share a range of other properties. A few elements have properties that are either anomalous given their category, or otherwise extraordinary. Metals appear lustrous, form mixtures when combined with other metals, tend to lose or share electrons when they react with other substances, and each forms at least one predominantly basic oxide. Most metals are silvery-looking, high-density, relatively soft and easily deformed solids with good electrical and thermal conductivity, closely packed structures, low ionization energies and electronegativities, and are found naturally in combined states. Some metals appear colored, have low densities or very high melting points, are liquids at or near room temperature, are brittle, not easily machined, or are noble or have nonmetallic structures. Metals comprise the large majority of the elements, and can be subdivided into several different categories. From left to right in the periodic table, these categories include the highly reactive alkali metals, the less reactive alkaline earth metals, lanthanides, and radioactive actinides, the archetypal transition metals, and the physically and chemically weak post-transition metals. Specialized subcategories such as the refractory metals and the noble metals also exist. Metalloids are metallic-looking brittle solids, tend to share electrons when they react with other substances, have weakly acidic or amphoteric oxides, and are usually found naturally in combined states. Most are semiconductors, and moderate thermal conductors, and have structures that are more open than those of most metals. Some metalloids conduct electricity like metals. The metalloids, as the smallest major category of elements, are not subdivided further. Nonmetals have open structures, tend to gain or share electrons when they react with other substances, and do not form distinctly basic oxides. Most are gases at room temperature, have relatively low densities, are poor electrical and thermal conductors, have relatively high ionization energies and electronegativities, form acidic oxides, and are found naturally in uncombined states in large amounts. Some nonmetals are brittle solids at room temperature. From left to right in the periodic table, the nonmetals can be subdivided into the reactive nonmetals which, being nearest to the metalloids, show some incipient metallic character, and the monatomic noble gases, which are almost completely inert. The characteristic properties of metals and nonmetals are quite distinct, as shown in the table below. Metalloids, straddling the metal-nonmetal border, are mostly distinct from either, but in a few properties resemble one or the other, as shown in the shading of the metalloid column below and summarized in the small table at the top of this section. Authors differ in where they divide metals from nonmetals and in whether they recognize an intermediate metalloid category. Some authors count metalloids as nonmetals with weakly nonmetallic properties. Others count some of the metalloids as post-transition metals. Oliver Sacks Uncle Tungsten. Within each category, elements can be found with one or two properties very different from the expected norm, or that are otherwise notable. Sodium, potassium, rubidium, cesium, barium, platinum, gold, manganese, iron, cobalt, nickel, gadolinium, terbium, dysprosium, holmium, erbium, thulium, iridium, gold, mercury, lead, bismuth, uranium, plutonium, boron, antimony, silicon, arsenic, antimony, hydrogen, helium, carbon, phosphorus, iodine,